Alright, draft science video. Okay, figured I'd do some work on some of this stuff I'm thinking about anyway. And see if I get inspired. I've been working on the programming thing, but it's not exactly doing what it needs to do. This started off with like 4 things, and it's just too much chaos in there. Yeah, so I haven't quite got haven't got it quite right yet. And I'm thinking it might take a while just because you have to do it and you have to cheat on the geometry to do it this way, and those cheats are probably going to be too many for the subtlety of the mechanism. But I really have to have a clear understanding of exactly what is getting exchanged. And so the idea is this thing. You know, red arrows bouncing off of blue, but it's really just about anything not your thing is what it comes down to. But anyway, I wanted to get to the Ken thing really quick. You know, the Ken Wheeler, the whatever, coward, that's all you can really call him. Talking about how he's he's a great debater and he's willing to debate anyone except not the crazy naked lunatics, anyone but that thing. I mean, he's a guy who uses all this excessive rhetoric, especially insulting the dead. I mean, he might as well call Einstein a pedophile. I mean, he's that short of it. In terms of this really excessive rhetoric, I mean, I've done nothing like that to Ken. I haven't been nearly that insulting. And so again, anyone but insane naked people, learn something. You as crazy as him? So I understand people just declaring big victory without having to do any work. I mean, maybe that's what all these sycophants expect out of life. The Tesla believers, they can't, they're afraid of having to argue with somebody who's actually got an argument. And so they just declare victory instead. But this just makes, it makes no sense considering the condition of this man. I mean, he is a fucking walking mess. And sit there and ridicule people because they don't wear a shirt in a video. I mean, it's just too silly on so many levels. So anyway, ironically or relatedly, I did a video. I'm not gonna switch the screens, but well, it's in my comments section on the video, the last video I did, the last live room, and my own amendum comment doesn't show up on, on my own video, where I quote one of those statements. And you're just saying, this commenting thing is just so broken. It's never assume your comment is published, even though you see it. Don't assume it's published, because clearly YouTube publishes comments at its own discretion. I can't possibly have my own account blocked somehow. I even made myself a moderator on my other account, and the comment still doesn't show. No, I'll show you. I mean, it's just, it doesn't make any sense. I have to wait for the screen to switch. So here you can see the comment I made, in the published comments on my comments thing. So it's there. I can see it. Okay, but if I look at the actual video, it ain't there. No sign of it. So, I mean, it shows up when I look at the comments, but it doesn't show up when on the video. Just not there. How does this make sense? Again, it shows up in Mendum. See, in Mendum, comment. Here's the guys don't know since when YouTube decided to deem every comment. So that's the comment. And on the actual video, don't know. Hey, where is that comment? Yeah, maybe that's the problem. Somehow the other guy's comment somehow is getting fucked with, so my comment doesn't show up because his comment doesn't show up. Well, anyway, it ain't right. I mean, obviously the comment isn't blocked or in the spam folder because it's on the published comments page. What happens when he simply hides and blocks the person? Okay, don't know since when YouTube. So 12 hours ago, you can see, relative to that one. So what happened was he simply, okay, so we go to that comment. Yeah, that whole comment said, there it is. Yeah, so it should have been here, right. So this comment doesn't have either this guy's follow-up or my comment. So neither one of them are showing on the video. Strange, that's all. Very strange. Anyway, alright, so, you know, I don't know. I mean, I'll obviously do follow-up videos on Ken, and I'll just put in the title something like fake, fraud, phony, because he doesn't have any rational excuse for this bigotry. I mean, that's all it is. And, again, my rhetoric has not been... I've even said, well, he's definitely an intelligent guy and blah, blah, blah. And I'm just pointing out why I think he's wrong. And I haven't used anywhere near the derogatory and insulting rhetoric he disposes constantly and gratuitously. So what's his excuse? He doesn't like people who don't wear their shirt? Bizarre. Fucking bizarre. Anyway, I did post a couple of photos to a couple of his photo contests, and he always left some sort of comment, like, you know, nice photo or some kind of thing. Why didn't he call me a lunatic then? If I'm a lunatic. Like I said, it just seems... I don't know why he is so... Why be so arrogant? Why claim you're the greatest knowledge possessor on the subject of field theory and claim that you're willing to take on all comers and then just so obviously prove you're not? And he almost references me when he's talking about these knuckle draggers and stuff. It's almost like he's talking about me, and yet he's claiming he's willing, and yet he's not willing. What is that? Except bullshit. Alright, anyway, back to physics. So the thing I'm thinking about is this whole idea of acceleration and the fact that something has to gain it, and the electron and how it functions. So, so let's understand how deep we are in the atom, right? So you have protons and neutrons in the nucleus, and then you have this idea of electrons spinning around. Now that's just an idea, right? They don't have cameras, so they can't really see that. I think electrons aren't doing this spinning thing. I think it makes more sense, even for chemistry, that it really is positions. So it's almost like those models you see of molecules, and the idea is that there's this extra electron. Well, it's truly an extra electron. It doesn't go anywhere. It's binding. Two things are magnetically connected to it. So if you think of them as magnets, you can sort of think that, yes, two magnets could share a little magnet in between them. So there could be a magnet with opposite polarity in between two magnets, and they're both being attracted to it, that kind of thing. So I don't think there has to be all this movement in atoms as they describe, but that's not really the point I'm getting to. So what I'm really trying to find out is what's holding an electron together. So let's understand an electron is a big blob of these little things, the photons. A lot of one-dimensionally moving things that only have momentum in one direction. They just go until they hit something, and they go straight. And you have this idea of a field that's full of stuff going every which way. So in a sense, there's an obligation, I suppose, to, like, if I was to say that if I was to describe it as an ether, you would start drawing it as, you know, there's lines, there's stuff going in all directions. So stuff's going this way, and stuff's going this way, and stuff's going this way, and so, you know, and so it's a real thick net of momentum, velocity, stuff moving. And so it's coming at you, essentially, like I said before. If this was the field, and you were to have one spot, this A, there's going to be stuff. Let's say if there was 1,000,000 pixels here, and we gave all the pixels a direction in just these 2 dimensions for now, you could sort of understand that from any position that this. So if I took one position, this little A, you could sort of understand that there's a certain number of each of these pixels that are all going to hit this A. They're going to go in all kinds of directions. You're going to hit everything the same way, but I'm just saying there's a certain number of them that are all going to go here. This is where they are going to end up being randomly. They're going to randomly end up at this location, going through this little A. And you'd get the idea of this kind of thing. You know, it would be, there's the little A, and it's going to be like it's the center of the universe, because anything that hits it, it's just going to be from all over the field. There's not going to be more from one side and less from the other side. It's going to be like a light bulb radiating, except in reverse. There's just going to be stuff coming in and hitting that one thing. So that's the world the electron lives in. So the idea is that the electron is sitting in a field of this kind of pressure. So I'll draw it as having a membrane, but it really doesn't. And the idea is, I guess we'll use one color for now. And this is the reason why I'm doing this is because I'm going to need to animate this, I think, to, you know, before my program thing is ready. So I'm thinking of making animations, and so I thought I would go through some of what the ideas are that I have to, and how I can convey them in terms of drawing them and animating them. So the idea would be is that the electron is full of these blue things. So let's just say they're blue. And anything not blue, it's going to do this reflection thing there. Okay, it's going to bounce off, or it's going to deflect the wrong color, so to speak. So anything not blue. And then the proton would be the same thing, but in red. So the proton's red-based, the electron's blue-based. And the trick is that anything blue that goes into this blue thing or hits it, it gets, the quandary for it is this quandary, right? I mean, there's no difference. The two worlds are the same. I guess I'm holding it upside down. But the interaction isn't going to be, you can't detect any interaction. It's as if they went right through each other or they completely reflected, but either way you couldn't tell the difference, and nothing as an end result changes in the universe, where there's obviously change in the opposite idea. Alright, so it's basically the rule is anything not blue gets reflected for this electron, and anything blue just goes right through. So if we understood that the stuff in the gravity pressure is full of what might be called, well, it's not blue mostly, right? Most of it's not going to be blue. Most of it's going to be some other color. So time to get another color. So I guess we'll use green just because it might show up better. And so regular gravity is going to be constantly pushing in is the idea. In a sense, not deliberately, but just as a consequence of this field energy. No matter where I put something, there's going to be stuff heading right for it, so to speak, and it's going to do it at a certain rate. And I guess that's the key thing I have realized. That's sort of the provocation for this video also, is the realization that the size of the electron is likely being dictated by the density of this pressure. If there was more pressure, then the electron could be bigger. That is, if there was more volume of this stuff heading right for it. And that, just finishing the drawing. So, yeah, I don't know if this is the best way to do a video, but it's the way I'm doing it, so sorry if it's a little bit tedious or irritating in some way. So the idea would be is that the stuff in the middle is trying to get out. So there's stuff just moving in straight lines, you know, going back and forth. And it's going back and forth in the sense that the blue stuff is heading in a direction, and it hits pressure, gravity, the little quanta bits, the gravitons, and it reverses direction. So the blue thing goes back this way, the green thing would go back out that way. So I guess that's part of what I need in this drawing, is a representation that as this pressure comes in, the polarization will be reflected. Now, what's really happening, okay, so I mean, I'll put these arrows going out, but I don't know if that's going to be entirely helpful. You probably can understand the idea that it's reflecting, but I guess I better do it just for, so you don't lose sight of that fact. So as stuff comes in, it's going to get reflected back out. And generally speaking, it's going to do so with the same polarization that came in. Anything not blue is going to get reflected. Now, you know, I've said before that reflections really are the thing that makes something move. Something gains acceleration by basically being a mirror to energy. The energy hits it and it reflects it in a sense, and that causes it to move. So reflections are through the mechanism through which something changes its momentum. It doesn't sound right, but if you think about objects that have some sort of built-in mechanism, like a super ball or a tennis ball, you can sort of get the idea that it's reflecting off of surfaces, and that if I hit it with something that has velocity, that it'll gain that velocity through a reflection. Okay, so back to where we was. Yeah, that's okay. Yeah, I'll say was. Back to where we was. Maybe a pen, regular pen might be good for drawing on my drawings. Let's see. So anyway, the stuff is coming in. So it's anything not blue is getting reflected. Anything blue, just goes right through. Nothing can change. So the idea is this stuff is constantly bouncing off of the pressure, so to speak. So you can sort of understand that there would be a density, an average density of pressure over time. So over the next hour, there's going to be an average number of these things, and there's going to be an even number in an empty space. There would be an even number coming from this side as this side, and this side, this side. So it's an even amount of pressure, and so the idea would be is that once this stuff is in a package, it would just keep bouncing off of that pressure. And the only thing that would be different is when something blue came in, because it would just go straight through. There would be no, if I made all of these green ones blue, you could sort of understand that that might be a problem, because then this stuff is going to head that way, because there won't be any pressure pushing it back. So anything that was going this way wouldn't get reflected, so it would just keep going. You know, and that would make this move. So blue creates a negative pressure essentially for the object. So if for some reason these were changed to blues, then this object would end up moving towards the blue, in the sense that its reflections would now go further. The stuff going this way would travel much further, and by the time they reflected, this field energy would have caught up and been further in. So the advancement would be, you can sort of get, I mean, it's a little subtle and complicated, but I'm just saying you can sort of get that if this arrow has to be longer because it goes further in because there's more blue, that it's, when by the time it returns the field, okay, so we'll use a squiggly line for the field energy, that it has incurred much deeper before this reflection happened. So now the reflection is happening in an advanced position because it keeps allowing this to catch up. So anyway, the argument would be is that anytime you have one of those changes, these deficits in the condition, that creates a change in the structure of this thing, because what's going to happen is if stuff is doing this, it's traveling more this way, and it's, in a sense, the new edge of this thing becomes here. So the edge is moving up here. What means this back edge is moving up here. And so anything in this back edge might get lost. Might get, the blue thing going here might just fly out this way, because it's no longer going to be part of the gang, kind of a thing. And so as something starts. So I'm just saying there's a consequence to an imbalance in the field. So any imbalances in the field in terms of the blues are going to create the possibility of a more aggressive movement. Now the inverse is also true. If I change the blues into a bunch of, let's say, reds, which are not blues, so the extra blues here end up getting changed to reds. The normal number of blues. So there's now less blues coming from one direction. Instead, they've been turned into something that's reflective. Then you can understand that the exact opposite would be happening. There would be more incursion. They would go deeper into this because they're using up all the arrows that might be going that way. And they're hitting them sooner, and because they're going in further to hit them. And likewise, then this other end goes out a little bit further because of that. And so anytime you do one of these imbalances, it becomes a kind of a permanent imbalance, even though you won't see it second to second over time. It's just a collection of heads and tails, and the thing becomes more tail heavy on one side than head heavy on the other side, and it'll just perpetuate that imbalance until something rebalances it. So that's the nature of the velocity of electrons. And the point to be made is that what is seen as a byproduct of this process is that the electrons produce a radiation, magnetism, when they do this, when they are converting, when they're being pushed, when there's an imbalance. And that creates this effect where they will release stuff outside of their perpendicular. So as they gain extra in one direction because of some imbalance in the field that's imbalanced the arrows inside of them, that imbalance will be reflected in the fact that it will sacrifice elements that are going inconsistent with the extra it's moving in this direction. So these arrows were lengthened essentially by gaining more blue this way. It's losing blue that way. Alright, I think that explains that. So the idea, what's I intend to illustrate. So again, the strong argument is that what's causing the repulsion between electrons is the fact that they're reflective. And so as long as they're not giving blue to each other, they're going to be throwing stuff at each other, so to speak. The field around them is going to be dominated by things that aren't blue. And that means things that are going to be reflective to other electrons. So you could almost understand that, I guess I'll have to come up with some symbol for a static electron. Right now I'll just use a cross with pretend arrowheads that you can't see because the marker's too big. So these are two electrons next to each other. And the idea is going to be is that what happens is that as one moves towards another one, it means it has absorbed some blue. So it's absorbed the thing that the other one's comfortable having hit it, in the sense that it's a no pressure thing. So let's say if there was a blue, wrong color, going this way from the field, this one absorbs it in the sense that I've just described it. It changes the line, okay, the edge of the pressure field is now changed. So it spent a longer time getting to this new edge, which meant the pressure from back here has now caught up, and now we have a new edge here also, and that we lost the blue this way, let's say. But the thing is the field had this blue in it. Now there's technically, in a random universe, now there's an extra blue over here. And because this blue won't compensate for that blue. And in fact, this extra blue has now been converted into a red, in the sense that the reflection that this represents, this freeing of the right color, means that a wrong color has likely been propelled forward. by that red. Not the right color, not blue, hits blue, blue. Alright. Let me draw this one separately so then it's no confusion. So remember, there's two kinds of interactions. There's the head-on collision, and then there's the tangential. So something can come into an electron this way, hits a blue, and the red will leave this way, and the blue will go down that way. So you can sort of understand that it's just we're changing the momentum of a color. So the color change, the change is that the momentum that comes in gets changed to a new color. So the blue the blue exchanges momentum with the red, and now the red exchanges momentum with the blue, and so the red is now moving in the other direction. So the point would be is that in these interactions of exchange, when you let something loose, you're essentially gaining something. So when you let something go from the back, you're likely gaining something from the front, and what you're going to gain is something of the red, the not blue polarization, and that not blue polarization will end up leaving. And so the point is that yeah, the point is that so anyway, so it's leaving the right, the good color, the blue leaves in the back, the not necessarily blue comes in from the front and is deflected, and so this ends up creating your potential for this perpetual reflexive reaction. So this isn't really necessary to the real point to recognize is that once a red gets between these two, it'll just constantly go back and forth and back and forth. It'll constantly be reflected. It doesn't have any other options. And so as these two things get closer, the pressure would increase because there would be more and more impacts per second. So that's essentially what's happening when you take two magnets of the same polarization and smash them together. You're essentially just increasing the number of interactions between those, that force that's between them, and it's not blue. So anything not blue is going to reflect. So that's the point I was trying to get to, and didn't do it very artfully. So the point is the only thing that can rescue a circumstance like this would be is that if there was some reason a blue going forward would produce blue going forward. And the argument is kind of obvious that any two things that are moving towards each other wouldn't be emitting the color they're using to gain acceleration. They wouldn't be letting it go forward, because then they couldn't possibly be going forward. If they're leaking the color that makes them in front of them, then they're obviously going to be going the opposite direction, not towards each other. So even from that perspective alone, you can sort of get the idea that things, when they move towards each other, are less likely to have blue in here. And without blue in here, you just have reflection in here. You just have stuff going to get reflected because it's not blue. Again, the only thing that can make blue things head for blue things is blue in between them. The more something else there is, the more hostile they're going to be, the closer they get to each other. I think you have to recognize that this is always the way it is. Everything really just goes in straight lines. Everything just continues on its path. Everything, nothing interacts in the sense that no momentum is ever lost in a direction. The only thing that can be trapped in the sense of being caused or forced to go backwards and forwards is polarization. Yeah, that's a good way to say it, I think, if you're getting my drift at all. You can't stop the fact that there is always force between things. So when I say there's a low pressure here, and there's high pressure outside of these two guys, I'm not saying there's less stuff here. It's just that it's less of the stuff that makes them compatible. that would make them, that would allow them to move towards each other. There's less of the invisible stuff, I guess is the way to say it. It's not technically invisible, so I don't. The compatible versus the incompatible. So I guess that's a way. Hostile versus friendly. So anyway, so there's always the same amount of arrows everywhere. It's just what color they are that's changing based on function, based on how much, what color is here will dictate what color can be here. Obviously, I think. Yeah. So again, the point I really wanted to make out of this, like I said, the thing that I've realized is this pressure is what, see, so the thought I had, okay, I'm saying, yes, these things are doing this internal pushing out while this is doing the pushing in, and that makes perfectly good sense why the blue stuff can't escape and the green stuff can't get in, is because there's just this constant balance between the amount of stuff of the blue against this all hostile stuff technically, and whatever stuff that's not hostile, there's an equal amount of it on both sides, on all sides, so it's irrelevant. And the idea, but my thought was well, how can something, why do these electrons tend to stay one size? Why don't they get really big or really tiny? And that's the key, is that the balance is really about how many arrows of pressure are heading for its center of gravity. So any one center of gravity always has the same number of arrows heading for it. So there's a constant and universal pressure exposure for any thing that could be called an object, and the object would have a center of gravity. All center of gravities are equally exposed to the universe, and so they have an equal amount of potential for these arrows to meet an arrow. So the idea would be is if there was some way to imbalance that, then you'd end up having more things going this way than that way. And as I'm trying to point out, is there's always the same number of arrows. So there's a point where it has to be one size, because this grid is one size. There's a consistency rule. You can't put more arrows in here because you can't make more field. So the only way you could put more arrows in is you could have the arrows that are in here have different colors. You know, you could have all kinds of different color ones mixed in here. But the point is they can't survive in here, because in here means this stuff is going to be always the wrong color. It's always going to keep pushing them out. So if they're not blue, they're going to get reflected and go right back the way they came. And so it's always like this line, it's never going to have a smooth surface or something. The idea would be is these arrows are pointing in a little here, they're a little short here, they're a little fat here, a little bit. It's constantly moving in terms of what the randomness of all these interactions. But the idea is it can't escape that consistency. So it always has to have that same what might be termed density. So as it gets bigger, the problem would be is there would be the Elysing line, if I can call it that, okay, the amount of fluctuation in this surface, alright, let's call it like that, would get big enough that the blues would actually go free. They would break free of the structure. So it would fall apart because there would be the Elysing lines would go too far, and the separation would be so great that something else from the field could hit it back here, and it would be just, it'd end up, that polarization would end up getting lost to other interactions outside of the protected area, so the herd. So this is almost like a herd argument. The herd fills all the spots, so nothing can really incur, because it has to go through so many spots to get to the interior spots, so to speak. And there's no way for it to make those incursions. It can only make incursions on the periphery. You can only take jabs at the periphery, and it can never make a cut deep enough to cause any real separation. All right. Anyway, so that's there's mechanics to all this that you could go deeply into that subject of exactly how how jagged an Electron line has to get before it's like 50% of those would break off or something like that. There's certain rules to this thing, and I don't have those ready yet, but so I'm not saying I'm not dealing with this in a deep enough way to be probably really tremendously useful. Again, I'm doing it more for my own clarity, that this is the mechanism, and just trying to understand, like I said, for every time you come up with a solution, it creates some sort of problem, and so you have to work through those problems. But I'm feeling very comfortable with the idea. Originally I was thinking that there was the possibility of some kind of actual orbit inside of an electron. That the pieces inside of it were swirling, doing some kind of thing like that to, and the pressure was holding the circles together or something. And I found that it's not necessary. So just as a galaxy functions, it's a round thing like a solar system, but it functions very differently because it's distributed the mass in the arms rather than distributing the mass primarily in the center. And so you can have a simpler mechanism of just stuff going back and forth, and understand that if you had pressure, that all you needed to do is go back and forth and back and forth and back and forth and back and forth, and that is the same thing as an orbit. As much as it doesn't look like an orbit, it's the same thing as a practical matter. It's contained, and it's contained in a diameter. And then you just do that in all the vectors there are, and you have a sphere. But the sphere isn't made up of things going spherically, it's made up of things just going back and forth. Just like the field is coming in radians, the force is going out in radians. Another way to put it. Excuse me. Dry throat or something. So I don't know if I need extra more on this. So that's just where I am, right? So I have to kind of fix this before I can fix this. And I would like to just do some kind of model that, like I can show you how this starts off and just doesn't do what it needs to as that starts off, and it just goes all over the place. But I still have in here this idea of things changing color, and I'm thinking they don't have to do that in hindsight. I don't need to load that video. Anyway, that you probably don't have to create extra or conversions of polarization to have enough polarization to create magnetism and all this stuff, but I'm not sure of that yet. I have to draw through it to get there. I guess I should have done something with the idea of the attraction between protons and electrons, but I think it can sort of be understood that if the protons are giving out the blue, so protons doing the red thing and the electrons doing the blue thing, that obviously the proton is reflecting all blue. It always reflects a blue, and the electron always reflects a red, so you can sort of understand that they are reflecting things that are invisible to each other. And so these blues will be conducive to the electron moving into the blue field, and these reds will be conducive to the proton moving into the red field. And so attraction is created. Even though what's really happening is it's the exterior blues that are putting pressure on the proton, and it's the exterior reds that are putting pressure on the electron. So, but anyway, it definitely works. Okay, so now I think that's enough. And yes, neutrons, I haven't messed with them yet, just because they are doing they're being a moderator, essentially, making it possible for protons to be forcing protons closer to each other than they might like. But in fact, they might be just neutralizing neutron. They just might be neutralizing the hostility of the proton by reflecting some of that hostile energy, polarization. So if neutrons are just reflectors, you can understand how they could be reflecting the hostility, polarization that the protons are emitting at each other. That's probably enough for that. So anyway, this is a little technical, I know, but it's important. I think, well, it's important to the people who are going to argue with the details. I don't know if it's going to be important to people who don't need a bunch of details, but need, well, like I said, just need the, show them the videotape, so to speak. Show them the generic mechanism, and then they can get that this function will explain gravity and magnetism, and that's almost everything. Anyway, so that's enough, I think. So till the next time, and such, pretty much.